Hello everyone, this is Arjun and welcome to ProCoder. We are going to take a look at a very interesting topic, linked list. These are data structures similar to arrays, but they have a lot of advantages. So these are data structures represented by nodes. It consists of dynamically connected nodes. Each node has two elements, the data and the link to the next node in the list, in the form of an object. But what do we mean by this? Well, let's say we have three elements on a linked list, 2, 5 and 8. We call the first element our head and the last element our tail. All the other elements are simply called nodes. So in this case, 2 will be our head, 8 will be our tail and 5 is going to be just a node. As you can see, instead of just writing 2, 5 and 8, we have created some extra spaces right over here. But what do we mean by these? Well, in a linked list, two things are stored instead of just the data. We store the data as well as the reference to the next node. So basically, this part of the first node will store the reference for the second node and the second node will store the reference for the last node. Since there isn't another node after the last node, it simply stores null value after it. This means that each node consists of two parts, object and the data, and the object will always store the reference for the next node. This object concept is very important to understand the working of linked lists. So from this we can say that unlike arrays, all nodes are going to be dependent on the previous node and cannot act individually. So what this means is that a second node that is containing 5 cannot be accessed without first accessing the first node, that is 2. You might think, why should we use linked list when we already have arrays? Well, these have some major advantages over an array. First of all, insertion and deletion of an item into or from a list is very easy, whereas it requires extensive data movement if we use an array. Another major advantage of linked lists is that we can always change its size, meaning we don't need to define its size from the beginning like we had to for an array. Its size changes itself whenever we add or remove an element. Linked lists are of three types: singly linked list, doubly linked list, as well as circular linked list. For now, we are just going to focus on singly linked list. Now we are going to take a look at the different functions that we have for a linked list. First, we can insert values into a node in three different ways. We can insert the value into the first node, into the last node, or in any inner node based on the index. We can remove a specific node, print or iterate over a list, or find the length of the list. There are many more functions provided, but these are the main ones that we use most of the time. Now we will take a look at inserting a node. Well, first we need to declare the linked list. So here's the syntax for doing that. We write linked list. Within these we are going to write the type, then the name equals to new linked list, and this is how we create the constructor. Okay, so now let's go ahead and add a node into a newly created list. So for that we can simply write list.add, then any integer, and by doing this our node is created. There is another function, that is list.addLast. If we add an integer over here, so by doing this 10 will be added at the end of the list, but by doing list.add the same thing happens. That means the number is added at the last. So these are the two functions which do exactly the same thing. So you can use either one of them. There is a reason for having two functions doing exactly the same thing. You will learn about it later on. Then we can also add an element at the start of a list. For that we write list.add first and then simply write the data. This is another function to add an element. For that we go list.add. Then we had the option to specify the index, as you can see over here, int index, as well as the integer. So if I write 1, 5, so what is going to happen is that 5 will be inserted at the index 1 instead of at the last or at the first one. In order to remove a node, we write list.remove. Here also we have three functions. In fact, we have more than three, but the main three that we use are remove, remove first, and remove last. We can also do like remove all, but those functions are rarely used. So we can do remove. By doing this, the last element of the node is removed. We can similarly write remove first to remove the first node, or we can go for list.remove and then specify the index within parentheses for the index of the node that we want to remove. Another thing that we need to do is iterate over the list. In array we simply use a for loop, but here the things are really different. You can use a for loop, but there is a better way to do it. I will show you both the ways. Here we use an iterator. This is also a class in Java. So for that we write iterator, then integer, that means the type of iterator that we want to create, then its name equals to name of our list dot iterator. By doing this we have created an iterator. So to iterate, then we use a while loop. So we write while iterator, the name of our iterator dot has next. Has next is another inbuilt function in Java. It checks whether there is a node present after our current node or not and returns a boolean value. After that, we can either print or use the current value using iterator.next. So in order to do that, we can store that value in an integer and write iterator.next. Using this, we get the next value in the iterator that we have right now. The second and more conventional way to do this is using a for loop. But for that, we first have to take the size. So to take the size, we write list.size. After that, we simply iterate over it like we used to do for array by saying I equals to 0 while it is less than the length and we increment its value. Then we can simply write int a equals to list.get. This is another function for list, and then we specify the index, which is going to be I in this case. So by doing this, we do the same thing that we used to do in array for writing int a equals to a of I. Another very important function in list is the dot contains functions. In arrays, if you wanted to check if there was an element present or not, we had to iterate over the whole array. Here we can simply write boolean check equals to list dot contains, and then we can check for any value that it has or not. If we write 5, it will return true because we have added 5 over here. So yeah, you can simply write list.contains to check for a value. These were the basic functions we have for linked list. I will link the Oracle website where you can find all the functions. We are not able to cover all of them as there might be around 50 of them. You can experiment around with them yourself, and if you have any issue, you can always discuss your doubt on our forum. I will upload the full program for this on our website, so make sure you check that out as well. It will be linked down below in the description. So I think we should also print our list, see what we have added till now. So let's see what the output must be like. First we added 5, then we added 10 at the first index. So instead of being 5 then 10, it will be 10 then 5. Then we added 5 at the index 1. So it is going to be 10 at the index 0, then 5, then again 5. After that we use list.remove, meaning that we remove the last element or the node. So after that, our list is going to be 10 and 5. Then we remove the first element or the first node, so that will give us 5. After that we are going to remove the element index 2, which is going to give us an index out of bounds exception. So we should also add a few more elements to make this work. So we can just go ahead and write a few more elements in here. So yes, after that we had only 5 at the first place, then we added 10, so it is going to be 5 and 10, then 5, 10 and 1. Then we finally added 11 at the second place, so it is going to be 5, 10, 11 and 1. Then we are going to remove the element at 2, that is going to be 11. So at the end we should get 5, 10 and 1. Let's go ahead and run this program. And also we are going to check if the list contains 5 or not, which in this case is going to be true. We will add another boolean to give us false value. We are going to add an element which is not there in the list, let's say 100. And then we are going to go ahead and print both of these. Let's run the program. So you can see, as I had said before, we got 5, 10 and 1, and since the list contains 5, we got true, and since 100 is not there in the list, we got false. In the next video, we will be discussing the implementation of linked list. It is going to be very important for the board point of view as well. So that is it for this video. Thank you for watching and have a good day.